Take a look at this picture of a stream. The first thing you notice is that the water is being brought downhill. The thing which brings water downhill is gravity, obviously. Water that is using gravity to go downhill is using streams and rivers to get to the sea. The water will either move slowly or quickly down the hill. This is called its velocity. Basically, velocity is the speed of moving water. It's recorded in distance over time. For instance, 1 kilometer per hour is a slow-moving stream, whereas 30 kilometers per hour is a quick-moving stream. It has a faster velocity. Gradient is the slope of the hill, basically the rise over run. So how much it decreases over the distance. The gradient is going to vary over the length of the stream. For instance, if we're talking about a mountain, the gradient is going to be very high at the top of the mountain, a big high slope. At the bottom of the mountain, it's going to be very flat, so it's going to have a very low gradient, not much rise over the length or the run. Number 4 is channel characteristics. The channel is the path that the stream follows. The water is going to encounter friction on the bottom and the sides of the stream. When it encounters friction, we're going to cause weathering. So water that is rubbing against the bottom and the sides of the stream is going to erode away that stream. We'll talk about some of the different streams and how the water will move, and then we'll discuss base level. Base level. Let's say you have a stream that is on land and it's making its way down a mountain to a sea, and it's going to be eroding away, kind of carving out the channel that it's moving down. All right, so it's cutting away at the bottom and the sides. As it cuts away, the lowest it can erode or the deepest it can cut down, the widest it can cut down is called its temporary base level. So we're saying temporarily, this is the bottom of where the stream can cut down to, or as deep as it can erode. Ultimate base level is sea level. So let's say you have your river and it's traveling down the mountain and it's heading out towards the sea. All right. You can't have a stream that's going to wear away more of the land than the sea level. So in other words, a stream cannot be deeper than sea level. That is ultimate base level, sea level. This is my jar of dirt. Okay, this jar represents water that is stable. The ground has been compacted for a long time. It's made up of gravel and sand and fine mud particles, and everything is settled to the bottom, and the water is very, very clear because it's sitting on top. This represents the sea. Okay, if you think about yourself in Lake Michigan, you have clear water, and then when you get to the bottom, you have sand to walk on. All right, and so that's at the bottom of the water. Now, if this is in a stream and it's traveling towards the body of water, we have this water constantly moving and it's constantly eroding and wearing away the bottom. So I'm actually going to shake this up and represent a stream that is moving. So now what you see is the water. It's not clear anymore, it's very cloudy, but very quickly you're going to see the larger particles start to settle. And the finer particles, which are suspended in solution, are going to take more time to settle. They're still carried in the water. As the stream moves downriver, you're going to get what's called discharge. Discharge means the water is going to drop off all of the sediment that it carries. So if this were a stream and it was heading down towards a body of water, it would drop off all of these sediments in a process called discharge. Just get rid of them. Take a moment and think about rain. Think about if you have a lot of rain pouring onto an area where there's a stream. the amount of water in the stream is going to increase. As that happens, the rate at which the water is traveling down the stream is going to increase. So we're going to have an increased velocity based on this increased amount of water. That is going to create an increased amount of erosion. So basically, as the water is ripping through the channel, it's ripping away at the sides and the bottom of the channel, causing more erosion. As a stream runs faster, it gets wider and deeper, and more water is discharged. As a river moves downstream, its velocity, width, and depth change with the increased amount of water it carries. When gradient decreases, discharge increases. So now you should basically be done. You will notice that you have one missing section on your worksheet that we didn't fill out. That's because we want you to fill in the blanks. So the part where it says, a smooth stream will move blank, a rough stream will move blank. Those two questions are about texture. So you're going to figure out whether the stream is going to move fast or slow. For a wide stream and a narrow stream, those two questions are about the size of the stream. You need to determine again whether they will be fast or slow moving. Finally, for the shape of the stream, if it's a windy stream or a straight stream, which speed will it move at, fast or slow? Once you've done that, you're totally complete, and you can bring this in tomorrow for your points.